Let's look at variations on the theme of graphing a sinusoid. In general, a sinusoid has this form, y equals a sine. This, for all the world, looks like a W. It's not. It's an omega. Omega x plus, this is phi, or sometimes you hear phi, just not pho or fum, phi, plus b. The good news is all of the pieces here do all the same things you already know about how to transform graphs. We're going to introduce some different words for some of this, but generally speaking, if you remember how to transform graphs of functions, it all works the same way that you already know. You might remember, and before you might remember, I'm going to say you can put a cosine in here, which is also a sinusoid, and it works. All this works exactly the same way for sines and cosines. So starting with this a on the outside here, you may remember multiplying a function by something on the outside causes a vertical stretch or shrink, and that's exactly the same thing it's going to do here. If a is 6, there's what my graph looks like. Instead of going from -1 to 1, now it goes from -6 to 6. It's a vertical stretch, and the only thing it affects is how high up and how far down from the middle my sinusoid goes. We give a name to this distance. We call it the amplitude. So the amplitude of this function is 6. If I go into negative values, putting a negative in front, you may remember, causes a reflection over the x-axis of my graph. There it is. So we're going to think of that negative sign and the value of a as being separate. The negative causes the reflection. The amplitude is 2, and amplitude's a distance. So we're not going to talk about an amplitude being negative. That kind of doesn't make sense. The amplitude is the absolute value of whatever a is. So my amplitude right now is 2, and this is a reflection because of the negative sign. I'm going to put this back to 1. I hope might take a moment. There we go. Okay. The next most prominent thing, I think, is the plus b on the end. You might remember that. Adding or subtracting a constant on the outside of the function causes a vertical shift. Up if b is positive, down if b is negative. And that's exactly what it still does. And we're going to call that a vertical shift. There is no special word for that. There was for the vertical stretch and shrink. We call it the amplitude. This is just a vertical shift, same as it ever was. Multiplying something by x, or multiplying x by a constant inside the function, you may remember, causes a horizontal stretch or shrink. And that's exactly what it still does. The bigger the value, the more compressed the function gets. And if I'm somewhere between 0 and 1, that's when it's going to stretch out. The sinusoids are periodic. Their period is 2 pi of just generic sine x or cosine x. So period starts at 0, next period starts at 2 pi. That horizontal stretch or shrink is going to change the period. We can find out what the period of the new function is by taking the original period, 2 pi, and dividing by the value of omega. So, for example, if omega is 2, the period of this function is 2 pi divided by 2, which is pi. And if you notice, there we are, a little bit over 3. That would be pi for one complete period. There's the next one. So omega changes the period of the function, horizontal stretch or shrink. Phi is a horizontal shift. If phi is positive, we're shifting left. If phi is negative, we're shifting right. Phi is intimately tied into omega. Since those are both horizontal ideas, if we have both a period change and a left or right shift, we're going to find the amount of the left or right shift by dividing phi by omega. We call this a phase shift. It's just a left or right shift. It gets its own word because these are sinusoids. That's a phase shift. So in general, there's how graphing sinusoids goes.